Mechanics of matter. Matter can be classified into solids and fluids. Solids tend to keep their shape when they are subjected to an outside force. The study of the mechanical properties of solid matter usually falls under the heading of solid mechanics. Fluids, on the other hand, deform continuously when subjected to an outside force. The study of the mechanical properties of fluid matter usually falls under the heading of fluid mechanics. Fluids can further be divided into liquids and gases. When acted upon by a force, liquids tend to keep their volume, hence we say that liquids are nearly incompressible. Gases, on the other hand, are compressible, and hence the volume of a given mass of gas can greatly vary depending on the outside forces that are exerted on it. Density is one of the important properties of matter, and it pertains to both solids and fluids. Hence we will cover density separately from the discussion of the properties of solids and fluids. When we discussed gravity, we saw that every physical object has a mass. Density is simply equal to the mass of a given amount of matter divided by the volume that the matter occupies. Density is usually denoted by the Greek symbol rho, and in metric units it is usually expressed in kilograms per meter cube. The matter for which we are obtaining a density value can be solid, liquid, or gaseous. The density of a given solid object, or of a given volume of liquid or gas, is not synonymous with the density of the material from which the solid object was constructed, or the density of the liquid or the gas matter. This is due to the fact that inhomogeneities can exist within a given volume of matter. Examples of inhomogeneities that can be present within a volume of matter are as follows. A solid object that is made up of a mixture of two different materials. The volume of water that contains air bubbles. The volume of gas that contains suspended water droplets, or dust particles. We hence define the material density as a material property that only depends on the type of matter. The average density of a given volume of matter, on the other hand, depends on the amount and types of matter present within that volume. The volume fraction of a given substance, that we will denote with the subscript I, within an inhomogeneous material that contains a number of other substances, is equal to the volume occupied by the substance I, divided by the total volume of the material. The volume fraction is usually written using the Greek symbol alpha, with a subscript that indicates the substance for which the volume fraction is being calculated. The summation of the volume fractions of all the substances within a given inhomogeneous material is equal to 1. In this case, we assume that the number of substances in the material is equal to n, where n is an integer that is larger than 1. By definition, the volume fraction is a unitless parameter since it has units of volume divided by volume. The average density of an inhomogeneous material is equal to the summation of the multiplication of the volume fraction by the density of every substance contained within the material. If the material contains voids, their volume fraction should still be calculated, and their density is equal to 0. The mass of a hollow wooden figurine is 100 grams, while its volume is measured at 250 cubic centimeters. The density of the pine wood from which the figurine was made is equal to 500 kilograms per cubic meter. What is the volume of the air that fills the hollow space within the figurine? We are given that the mass of the figurine is equal to 0.1 kilogram, and the density of the wood from which it was made is equal to 500 kilograms per meter cubed. The equation for the density is as shown. We can rewrite the equation for density to solve for the volume of the figurine if it was made of solid wood. By plugging in 0.1 for the mass and 500 for the density, we get a solid figurine volume of 200 cubic centimeters. The actual volume of the hollow figurine, however, is equal to 250 cubic centimeters. Subtracting the solid volume from the actual hollow volume, we get the volume of the air within the figurine. By substituting the values, we get the volume of the air within the figurine, which is equal to 50 cubic centimeters. The water flowing within a certain pipe contains air bubbles. The number of bubbles per meter cube of water volume is equal to 1 million, and the average volume of a given bubble is equal to 0.25 cubic centimeters. Given that the density of water is 998 kilograms per meter cube, and the density of air is 1.2 kilograms per meter cube, what is the average density of the fluid that is flowing through the pipe? First we need to find the volume fraction, occupied by the air bubbles. We can get this by dividing the volume of air contained in a unit volume of fluid, by the value of the unit volume. In this case our unit volume is equal to 1 meter cube. The volume of air in 1 meter cube of fluid, is equal to the average volume of one bubble, multiplied by the number of bubbles contained within 1 meter cube of fluid. Hence we find that the volume fraction of air is equal to 0.25. The summation of all the volume fractions must add up to 1, and there are only two substances present, air and water. Thus we can find the volume fraction of water, by subtracting the volume fraction of air from 1. We get alpha water equals to 0.75. Finally, the average density of the fluid can be calculated by adding up the multiplication of the volume fraction, by the density for all substances within the fluid. Hence O average is found to be equal to 748.8 kilograms per meter cube. The specific gravity of a given substance I, is equal to the density of that substance, divided by the density of water. The specific gravity is denoted with a capital S, followed by a subscript G. The density of water, is almost equal to 1000 kilograms per meter cube. The specific gravity of water, is equal to 1. The specific weight of a substance, is defined as the force due to gravity, exerted by a unit volume of that substance. It is written as gamma, and is equal to the density of the substance, times the gravitational acceleration. The specific weight has units of newtons per meter cube. The specific volume of a substance, is defined as the volume that is occupied by a unit mass of that substance. It is equal to 1 over the density of the substance. The specific volume has units of meter cube, per kilogram,